In this video, we will see how to find the net or the resultant electric field at a point in a system of electric charges where we have to break down one of the vectors into its components. Find the net electric field at point C. As you see in the system, we have QA, QB, and point C is located there. This position is on the x-axis, but it is not at the right angle of the triangle. So let's see how we do this. The first step is always to draw the vectors, to draw the electric field vectors and their directions, to show their directions. We cover QB. Now for QA, QA is a negatively charged object. Then the electric field created by QA at point C should converge towards A this way. Then we uncover B and we cover A. Since QB is a positively charged object, then its electric field should diverge away at all points. So at point C, the electric field created by B should be pointing away or diverging away from B this way. Now we start the calculation. To calculate EAC, we use the formula KC QA over RAC squared. QA is given, we know its value, but RAC, which is this distance, is an unknown. In this yellow dashed triangle, RAC is the hypotenuse, then it's equal to RAC squared is equal to RBC squared plus RAB squared. So we find it this way. We square root both sides. We replace the values and we get the answer as 5 meters. Now we have Kc, we know its value, 9 times 10 to the power of 9 coulombs constant. Qa is negative 2 microcoulombs, we have to convert it to coulombs. And RAC, we found it as 5 meters. We replace the values and we get the answer for EAC, the magnitude or the strength of EAC, as 700 newtons per coulombs. Now we calculate EBC, which is KCQB over RBC squared. KC is 9 times 10 to the power of 9. QB is given as 4 microcoulombs. We convert it to coulombs. The distance from B to C is given as 4 meters. We replace it and we find the answer for EBC as 2250 newtons per coulombs. Now we think of E net. Okay, we check the vectors. Are they on the same dimension on the x-axis or the y-axis? No, they are not. Okay, are they on the y-axis? No. So they are not linear. I cannot add or subtract. Are they perpendicular to each other? The answer is no. So the only way to solve this is that we check them. EBC is already on the x-axis, but EAC is not. So I have to break down EAC into x component and y component. I take EAC and I put it on a separate axis. Now, to calculate the components, I draw them. This is EACX, I project it on the x-axis, and on the y-axis, EACY. To find EACX and EACY, I need an angle. So if I compare, I have this angle, which is similar to this one, between EAC and the negative x-axis, between EAC and the negative x-axis. So I will call it alpha on both sides. Now, how to calculate alpha? If we go back to the main figure, alpha is an angle in this dashed triangle. The opposite side to alpha is 3 meters, and the adjacent is 4 meters. So I can use the tan inverse function to calculate the angle alpha. So alpha equals tan inverse of opposite over adjacent, 3 over 4, and we get the answer as 36.87. Now, we calculate EACX and EACY. How do we choose? If you take this triangle, this one, in this triangle, this is angle alpha. Its adjacent is EACX. The adjacent always relates to the cosine function. So EACX is equal to EAC cosine alpha. And this is the opposite side, the vertical dashed line, which is equal in length to EACY. So it replaces EACY. The opposite relates to the sine function. So EACY is equal to EAC sine alpha. Now it's time to calculate E net x, which is the resultant electric field along the x-axis, and E net y, which is the resultant electric field along the y-axis. For this reason, I will copy EBC and I will add it to this axis. Now, EACX, we have EBC minus EACX. So for E net x, it's equal to EBC minus EACX, or EBC plus minus EACX. We replace EBC, which is 2250, minus EACX, which is 576 newtons per coulombs, and we get the answer. Now for E net y, we check the y-axis. We have EACY going along the positive y-axis and nothing along the negative y-axis, so it will be E net y, or the resultant electric field along the y-axis, is EACY minus 0. We replace EACY is 432 minus 0, we will get 432 newtons per coulombs. When we say E net x, then it is a vector along the x-axis. E net y is a vector along the y-axis, which means that E net x and E net y are perpendicular to each other, or at a 90 degrees angle. So the net electric field, or the resultant electric field, is E net equals square root of E net x squared plus E net y squared. We replace the values of E net x and E net y, and we find the final answer as 1729 newtons per coulombs. This is the magnitude, or the strength, of the resultant electric field. Since the electric field is a vector quantity, then we have to find its direction. To find the direction of the resultant electric field, we construct a new axis where we will add E net x and E net y. E net x goes along the positive x direction, since I got it as a positive answer. If it was negative, it will point along the negative x direction. So since E net x is on the x-axis and it is positive, then it points in the positive x direction. Now, E net y, same thing, it's positive, so it points along the positive y direction. Okay, this is E net. The direction for E net will be the reference angle from the positive x front, which means it will be this angle from the positive x front counterclockwise to this point. So we consider this angle as theta. To find it, it is equal to tan inverse opposite over adjacent. The opposite with respect to this angle is this vertical dashed line, which is the same as E net y in magnitude or in length, and the adjacent is E net x. So tan inverse E net y over E net x. We replace the values and we find the angle theta as 14.47 degrees. Now the direction, or the reference angle, since this vector is in quadrant 1 and the angle is laying along on the x-axis, then the direction will be 0 plus theta. If I found the other angle, it will be 90 minus alpha. Okay, so I found this one, then it's 0 plus the angle. So this is the direction for the resultant electric field in this system.